Morning everyone. Are you able to hear me?
Yes, sir.
Yes, sir.
Okay, we'll just wait for one more minute for others to join and then we'll start with the lecture. So good evening everyone. I'm your mathematics teacher, Mr. Hemant Mehta. Okay, I'll not waste much of the time of our class. I'll give a very brief introduction about myself. Uh, I'm an aeronautical engineer as well as MSc in physics. At the same time, I have a teaching experience of more than 7 years. I have published research papers into international journals, and I also work with an organization which works on satellites. That is IDYM, and there is an organization. Okay, so without wasting much time, let's start with the today's session. And you can see the topic on the board is basic mathematics. So before me starting, I want you guys to tell me what is maths as per you. You can unmute yourself and you can answer me. You can unmute yourself and you can answer me. What is maths as per you? Everyone, please, at least I need some 3 4 answers at least. Let it be an interactive session. If it's only lecture, then it becomes a little bit bored. Please, any of you, what is math as per you? I'm not asking you the definition, I'm just asking you your perception. As per you, what do you perceive? What is math? Anyone, please? Do not put on the study of numbers, shapes, patterns. Good. Study of numbers, shapes, patterns. Very good. Anything else? All answers are right. You just give me answers. What is math as per you? Because the topic is basic mathematics and we are going to start from very basic concepts in today's lecture. And if we are able to complete, then we'll start with the first chapter also. Any other answers, please? Other students, please, you can unmute yourself and you can tell me, otherwise you can put it into the chat box. Please, what is math as per you? One answer has already come, study of shapes, numbers and patterns. Very good. Other answers, any other answers? Signs of numbers, good. Very good. Deals with problems, but what kinds of problems? Physics also deals with problems, chemistry also deals with problems, biology also deals with problems. What sort of problems? Numericals. So we have numericals in chemistry also, we have numericals in physics also. Okay, good. Deals with numericals. Any other answers? Okay. Today's lecture is really going to be interesting. Topics related to quantity, structure, space, and change. Okay. Quantity, structure, space, and change. Very good. Very good. I'm really liking your answers. This is the first class in so many years where I'm getting some different answers. And all answers are right. And I'm getting some different answers. Otherwise, for others, maths is only numbers and equations. But I've got many different answers. I'm very happy. So you have a good understanding of mathematics. So let's start. So what if I say that mathematics is a sense you had, but you never knew? What am I saying is math is a sense you had, but never knew of, that you had this sense. What if I say it is a sense? Sense like our sight, our touch. I can say mathematics is the sense which everyone has. No one is weak in mathematics. Everyone has this sense, but only the matter is we never knew it. Let me make it a bit clear. You had length formula in your 10th standard science. It says something like this: 1 by f is equals to 1 by v minus 1 by u. Now, why have I written it? Because you very well know that you will be able to see even only if the image is formed on retina. If the image is not formed on retina, then you will not be able to see the image. And if I am walking here, I am changing my position continuously, and if you are able to see me, what does it mean? It means that the image is formed on the retina, and that is why you are able to see me even when I am changing my position. So this thing in your science is studied as power of accommodation, where this is fixed for our eyes because this has to be your retina only. So image distance is fixed in our case of our eyes, and which we have studied as power of accommodation, where the object distance is changing, which in this case is me. In this case, it's me. Okay. At each and every moment, I am changing my position. At each and every moment, okay, this object distance is changing. The image has to form on retina. Then what does the eye does? It changes its focal length. It changes its focal length continuously so that the image is always formed on the retina. So you very well know if you put V and if you put the value of U, you will get the value of F. So your mind is continuously calculating, okay, when me, the object, is changing my position, okay, it is calculating how much amount of focal length should be there, how much force should be applied on the crystalline lens inside your eyes so that certain amount of compression or elongation can be produced so that the focal length of the eye changes by such an amount and the image is formed on the retina. So within fraction of seconds, all these calculations your mind is doing. Your mind is doing all these calculations. It is giving instruction to the ciliary muscles. The ciliary muscles is compressing or okay, or enlarging your crystalline lens, because of which the image is always formed on the retina. Continuously the calculation is going on in your mind, and your hands are working. If you want to move the hands, okay, if you apply more force, the hand will go more behind. If you apply less force, the hand will go up to here. And if you know by how much till where I want to bring my hand, okay, your hand will go up to that much part only. So again, mind is calculating how much amount of force should be applied to the muscles so that hand gets raised up only up to this point and not further more. So what I mean to say over here is, we already have this sense. Our mind always works in this manner, in the sense, okay, where it is calculating the things every time. Our mind is mathematical, and I say that mathematics is a sense. Okay, mathematics is nothing but a sense which we had, but we never knew. Yes, all these things, whatever you have said is right. Everything is a part of mathematics. But I want to highlight one more thing. I want to highlight one more thing today, and then we'll start with some basic mathematics. I'm just sharing my screen. Just a minute, I'm sharing my screen. Are you guys able to see this image which I have just shared? Are you guys able to see? Yes or no? S or yes? YES? I don't understand how the short form. You're able to see the image on your screen? Okay, okay. So you can see there is an image on your screen which you can see. This is the river before it joins the sea, okay, which we call it as a delta, okay, which we call it as the river delta. This is the picture of the river delta. One more image. Are you able to see this image of a tree? Can you find any similarities in it? Can you find any similarities in it? Concentrate on the similarities. So, whatever you have said, I accepted all these things. And let me add one more thing, mathematics. Okay, mathematics is not only about numbers and all these things, it is also about patterns, which is already written over here. It is also about patterns, relations, and logical connection. Mathematics is not only about numbers, it is not only about shapes, okay, it is also about patterns, it is also about finding relations between similar or dissimilar quantities. and it is also about logical connections. Okay, connecting to things. It is also about logical connections. Geometry, shapes. So it is not only about the shapes which you have studied, that is square, rectangle, quadrilateral, triangles and circles, okay, and spheres, cylinders and cones, all the shapes which you see. And that is why the name which you must have studied is called as geometry. Geo stands for earth. Geo stands for earth, and I'm using the word this geometry where you are studying about all the shapes. Why we must have used the word called as the geometry? Earth. On the earth, you see hell lot of shapes. It's not only about the shapes which you have studied. Are you guys there online? Uh, are you guys able to hear me clearly?
Good evening, ma'am.
Only one student is there. Where have others gone?
Good evening, sir.
Where have others gone?
Good
All
evening,
are having
sir.
network problems.
Good
Yes,
evening, sir.
others
Sir, your
you
voice
able
is
to.
breaking.
My voice is breaking.
Yeah, yeah, yeah. Okay, sir. It's normal. It's normal.
Now is my voice clear? Now is
Yes, sir. Yes, sir. It's
yes.
clear. Yes, sir. Yes, yes.
Okay. And are you able to see the presentation which I am showing?
Yes, sir. I'm able
And
to see the
it is
presentation.
suddenly everyone has disappeared. What happened? Suddenly everyone disappeared. All are facing network issues. Okay, no worries. We'll continue with the lecture because that is a recorded session. So those network problems will be able to see it afterwards. Okay. Uh, so I was saying about mathematics is also about patterns, relations, and logical connections. Whatever we have written over here, yes, all this is also part of mathematics, and it is also patterns, relations, and logical connections. So I have shown you two images. One image was of the river delta, and the other image is about this tree. Okay, just concentrate on the similarities. So I have one more for you. So at one moment we think that this is the pattern which I showed you. Okay, this pattern is somewhere only, but this pattern is repeated everywhere. And each one of you who is attending this class today, okay, each and every cubic cell, each and every cubic, okay, centimeter of your body has the same pattern. Not only the river delta, not only the tree, not only the lightning, okay, this you can see, this is the blood capillaries. Okay, this is similar pattern, and this is what we call it as fractals. This study of mathematics is what we call it as fractals. And once you have the sense of this fractal, okay, once you have the sense of this fractal, you'll be able to see this pattern. Okay, so are you able to see this
Sir, I
visual
can see the presentation, sir.
You're able to
Yeah, I
hear
can
me
see the
clearly?
presentation. Yeah, I can see.
What happened? You're not able to hear me clearly?
But I can see the percentage clearly.
You're able to hear me? Is there
Yes,
any
sir, I can
problem?
see you. But the board's letters are not visible clearly. So I can see you, but the board's letters are not clear. But I can see presentation.
Sometimes what happens is if our internet speed is low, okay, then the voice is clear and the video is blurred because the video requires
Yes, sir.
more
Yes, sir.
data
Okay.
than real data. So you don't worry if you're not able to see the things
Yes, sir.
clearly.
Okay, sir.
We will share you the recorded video. So in that recorded video, the things will be clear. Okay.
Yes, sir.
If
Yes,
there
sir.
is internet
Okay, sir.
problem on my side, or if there is an internet problem on your side, then the video becomes blurred. Okay.
Yes, sir.
And
Okay, sir.
therefore, you don't worry. But audio will, in 99% of the cases, the audio will be clear.
Okay, sir.
Because I'm sharing you the screen and I'm talking about those things. So at the last, let me say that this is the mathematical reality which we see everywhere, be it delta, be it the trees, be it the lightning, or be it every inch, okay, every cubic centimeter of our body, which is filled with the okay, these patterns are repeated everywhere. So this is how mathematics enters the fabric of the universe, okay, and shares the similar kind of thing which we call it as a fractal. So without wasting much of the time, this was just an introduction about mathematics. One more thing before leaving off, I am showing you one more image. Now this you can see this is called as rotational symmetry. Okay, you must have seen symmetry, mirror images, our body, okay, about the vertical axis is mirror image. So if we fold our body, the things will overlap on each other. So if on the circular and the if we have symmetry something like this, then it is called as rotational symmetry. I'm just showing a figure to you. Now this is again a pattern and the trees, the plants, okay, they and the flowers when they come out, they spiral and then they become like this. So we see flowers and all these things. If you watch it from anywhere, you will find out that it is the same thing, unless and until you mark any of the pattern. Okay, if you rotate it, okay, you will find out that from everywhere it is same because it grows spirally. So now if the when it is spiraling and if the angle is 90 degree, then it will form like a cross. If say the angle is 62 degree, then we get something like this. But the angle is 7.5 degrees. If the angle is 137.5 degrees, okay, then you get what you are seeing over there. So if you see any flower at the center of the flower, okay, where the petals are attached, okay, that you will see that pattern and that pattern, such a pattern is developed to maximize, okay, the things in the given area, whatever given area is there, their maximum cells or the maximum structures I can place. And let me tell you, this is something like in maths which we call it as golden ratio. It is present everywhere in the structure of our hands, in the structure of our body, in the structure of our hair, in the structure of our eyes, in the structure of our face, in the structure of the flowers, everywhere this is present, which we call it as golden ratio. Similarly, we have something called as fractals and something which I just showed you, which is the spiral or the rotational symmetry. So before signing off, what is mathematics? Okay, I think I am able to satisfy you and able to inspire you to change your outlook about mathematics. Okay, away from the numbers, away from anything that is more than what we see. Mathematics, if we see in this way which I have showed you today, will help us to develop the sense of the universe. So let's start with the basic mathematics. This was just as to introduction about what is mathematics. So today we are going to talk about basic mathematics, and when I say basic mathematics, which means very, very, very basic math. Okay, let me start with very basic multiplication. Can you tell me what is multiplication? Or can you tell me why 5 into 3 is 15 and why 3 into 5 is also 15? Why? I'm going to start with very basics. These are fundamentals. Once we come into 11th and when we are thinking about JW, okay, our fundamentals have to be very, very strong. If I want to get into IIT, I don't only have to give mains, I also have to give advanced.
Okay, sir.
And you see the advanced questions when we'll start solving, you will realize that you require a very strong fundamental. If our fundamentals are weak, we will be able to solve mains, but will not be able to solve, okay, will not be able to solve advanced questions. Therefore, our fundamentals should be very strong. So I'm asking you a simple question. I'll just sign off from my laptop.
Yes, sir, I can see.
Okay. Now you'll
Okay,
be
sir.
able to see the board clearly because before that I was presenting the screen. What
Okay,
happens
sir.
is the screen share will look bigger and the board will look smaller.
Yes,
Now
sir.
you'll be able to see the screen. Okay. So
Okay, sir.
let's try to prove this. 5 into 3 is 15. 15, so you will be saying, sir, what simple thing you are asking? Here, by well, 5 3s is 15 and 3 5 is also 15. And therefore, it is. But that is what I am asking. Why 5 3s is 15? Or 5
Yes,
3s.
sir, because it's a mathematical rule.
So let's try to see what multiplication is nothing but addition. So when I'm writing 5 into 3, it's 5 times 3. When I'm writing 3 into 5, it means 3 times 5. So here I have to add 5 into 5. Okay, what it means, I have to add 3 into 5. And what 3 into 5 means, I should add 3 into 5. So multiplication is nothing but one type of addition. And 5 plus 5 is 15. 3 that gives me 15, and that is why we can say 3 into 5 is 15 and 5 into 3 is also 15, because what is multiplication? Multiplication is a type of addition, and that is why 5 into 0 becomes 0. Why it is 0? Because it means 0 times 5. So how many times I should add 5? I should add 0 times, and that is why 5 into 0 is 0. Why? Because I have to 0 times 5. So how many times I have to add 5? 0 times. So but obviously I don't know I have to add anything. 0 times I have to add 5. When I write here, I have to add 5 3 times. When I write here, I have to add, okay, 3 5 times. When I'm writing 5 into 0, I should add 5 how many times? 0 times, and that is why you get 0. Okay, so multiplication is nothing but addition. Next important concept, division. Can you tell me what was division? So division is nothing but repeated subtraction till you get 0. So division is also nothing but a type of subtraction. Okay, and how much you have to subtract? You have to subtract till you get 0. So if I ask you, 15 upon 3 is 5. Write this definition. What is this definition? So when you write 15, how many times I can subtract 3 from 15? So 15 minus 3, 12 minus 3, 9. 9 minus 3, 6. 6 minus 3, 3 minus 3. So how many times I was able to subtract? 1, 2, 3, 4, and 5. And that is the reason why we write 15 upon 3 is equal to 5. And that is why 15 divided by 3 is nothing but 5. These are the basic fundamental things which we know, which we should know. And on basis of this, we are going to study a concept called as infinity. A very important infinity is a concept rather than a number. Infinity is a concept and not a number. In your 10th standard in trigonometry, you must have seen this symbol. Okay, 1 upon 0. When you write sec of 0, sec of 90 degrees, so it becomes 1 upon cos 90, that is 1 upon 0. And you must have written infinity over there. Okay. So, infinity is also called as non. And we are going to say this. Why do we say it as not defined? Why should we call it as a concept rather than a number? So, on basis of this, if I write 15 divided by 0, what does it mean? Okay, your division is nothing but repeated subtraction. So, how many times can I subtract 0 from 15? Okay, to get 0. How many times can I subtract 0?
Common 0, sir. 0 times 0.
Infinite times.
Oh,
Yes or no?
yes.
Because
It is
15 minus 0 is 15. Again minus 0, 15 minus 0 is 15. Here what we did, 15 minus 3, 12, 12 minus 3, 9, 9 minus 3, 6. But when I do 15 minus 0, I am going to get, okay, I will able to do infinite things. So here we wrote that I am able to subtract 3 5 times, and therefore I told that my 15 divided by 3 was 5. So 15 divided by 0 will be how much?
okay, sir.
So we write infinity, right?
Yes.
But if I write 1 upon 0, then 1 minus 0 minus 0 minus 0 minus 0. How many times I will be able to subtract 0 from 1? If I write 10, so this also gives me infinity. Then what does mathematical rule say? The mathematical rules say that if RHS is equal, then LHS should be equal. So, if I say 1 upon 0 is equal to 15 upon 0, because both are giving me infinity, and if denominator are same, it gets cancelled. Is this right? Can 1 and 15 be equal? Can
Okay,
1
sir.
and 15 be equal?
Maybe.
No. Okay. If we put mathematical rules over here, this is not following my mathematical rules. Let me give you one more example. 1 upon 0.1 will be how much? 10.
10, 10.
0.01 will be how much? 100. 1
0.1
upon 0.001 will be how
thousand.
much? 1000. If I keep on doing it,
Infinite. You go
whatever
on,
numbers
sir.
are there,
You
that
go
will,
on.
if you guys say your 1, 2,
10,000.
3, 5.
10,000.
So if I continue like this, okay, if I
Infinite.
continue like this, won't I get infinity at one point because it is going on increasing 10, then 100, then 1000, then 10,000, then lakh, then crores, and okay, it will go on increasing. So can I say that if I keep on doing this procedure, I will reach to a point where I can call it as infinity? Let me do one more. If I write minus 1 upon 0.1, I'll get minus 10. If I do minus 1 upon 0.01, I'll get minus 100. If I do minus 1 upon 0.00001, then I'm going to get
Sir,
zeros are there and that is minus. So if
sir,
I keep doing it like this,
sir. Then if
I'll
you are
get,
putting,
yes, what
sir,
happens?
sir, if you are putting then one minus, sorry, minus one by 0.1 means we should put minus value, sir.
But obviously, it is if minus upon 0.1, how you can write this 0.1? You are going to write it as minus 1 upon 1 upon 10. This is one
Okay,
point.
okay, okay, sir.
0.1.
Okay,
So
sir.
this 10 goes up, so minus 1 into 10 is going to give you minus 10.
Okay, sir. Okay, sir. Okay, sir.
So if you keep on doing it, you will always get these negative numbers.
Okay, sir.
So now I can say that I am reaching to minus infinity. So up till now I was just getting positive infinity. Now I'm also getting minus infinity. Okay. So I'm going somewhere else. If I do the similar procedure but 2 minus 2. So minus 2 upon 0.1, which will give me minus 20. Okay, minus 2 upon 0.01, that will give me minus 200. If I keep on doing it, then this also will get minus infinity. Now, this time what happened? I am getting minus 1 is equals to minus 2. Is this possible? It is not possible. Okay, it is
Sir,
not
another one
possible.
has joined.
What's
Sir,
happening over here?
another one
What
has
is
been
happening?
joined.
Start treating infinity as a number. Okay, none of the mathematics which we have done till the date will get satisfied. That is why we say we don't know what is infinity. It is not only countless. It is not only countless, but when I'm doing something else, I'm getting 15 is equals to 1. I can get 100 is equal to 10. I can get minus 1 is equals to minus 10. I can get minus 1 is equals to minus 2. Whatever algebraic principles are not going to get satisfied. And therefore, we see infinity as not defined. And therefore, it should be seen as a concept. It should be never be seen as a number.
Okay, sir.
Because if it is a number at the first place, okay, then it has
Okay,
to
sir.
be okay, rules which we have created in mathematics. If it is not following any of the rules of mathematics, which means, so similarly, if I write infinity plus infinity, so it is not going to be no infinity. Similarly, if I write infinity minus infinity, it is not going to be zero. It is not a number. It is not a number. It is not going to satisfy any rules of your algebra. Since infinity is not a number, it is not going to satisfy any rules of your algebra. Therefore, infinity minus infinity is not going to give you 0. Infinity plus infinity is not going to give you 2 infinity. Similarly, infinity into infinity will not be infinity square. It is not going to satisfy any rules of algebra because infinity is not a number, it is not defined. I've already proved that if I start taking it as a number, I'll get everything weird in your mathematics. And therefore, infinity cannot be treated as a number, it should be treated as a concept and it is not defined. We mathematicians don't know what is infinity, and that is why we take it only as a concept. Okay, so
Okay, sir.
now we also know, which you have studied in your lower standards, that anything upon zero is infinity. Anything means anything. 1 upon 0 will also be infinity, 15 upon 0 will also be infinity. And hence we should say that infinity is not defined. We have seen today multiplication is nothing but addition, division is nothing but subtraction. Infinity is a concept, it's not a number. It doesn't satisfy the rules of algebra. So now we are going into much more. So we have started with basic mathematics. So now we are going to start with the number system. Okay, maths is
Yes, sir.
not only numbers. We started our lecture with this today. Okay, but we deal
Okay,
with a
sir.
lot of numbers in our maths. So basically, numbers are of two types. One, which are called as real numbers, and there are the other which are called as imaginary numbers. Real numbers are denoted with capital R, whereas imaginary numbers are denoted by small I. Don't worry about imaginary numbers. I'll give you a very small introduction. And we have an entire chapter called as complex numbers,
Okay, sir.
okay, which is based on imaginary numbers only. Now, real numbers, which we have studied in our low classes, we know these are of two types again: rational numbers and irrational numbers. The rational numbers are denoted by capital letter Q. Irrational numbers are denoted by capital letter Q dash. Now, in rational numbers, we have natural numbers denoted by capital N, whole numbers denoted by capital W, and we have integers denoted by capital I. So instead of top down, let's move from bottom to top. So the natural numbers starts with our mind when we had not even developed the numbers. What happens is when our mind, when you are seeing, when you are sitting at your place, at your home, and when you are seeing in front of your eyes, you are going to see a lot of things, and your mind is going to group them. If you just pay attention on it, okay, it is going to separate. So he'll say that yes, your mind will say yes, this is a tube light, this is a fan, this is so and so, and it is going to group it. And then your mind will say there are two fans, there are say four tube lights, there are two pens, there are two bags, there are two chairs, and so on. our mind works in a mathematical way. So initially, when we develop the number systems as the history of our human behavior starts, okay, so we named symbols. Okay, one will be shown by this symbol, two will be shown by the another symbol, and so on. So different languages have different numbers, but the logic remains the same. So there came the natural numbers. We started with one because we started with reality, and we went up till countless numbers. Then the zero was introduced, okay, from India, and then that zero got involved in the which we called it as whole numbers. So natural numbers which include zero also, then that will be called as whole numbers. So again, it consists of positive numbers only. As we progressed further, we wanted to give direction sense. Am I going in this direction or am I going in this direction? So now to give the direction sense or to explain how much less I have, not how much more I have or how much less I have. Okay, negative numbers were introduced. Okay, if I wanted 5 pens and I have only 2 pens with me, which means I need 3 more pens to become 5. So I lack by 3. So how should I
Okay.
explain that? That is where
No.
negative numbers came. So negative numbers and all the positive numbers together came to be known as integers. Okay. Then fractions were discovered. When we are dividing the things, we get fractions, and therefore we call it as rational numbers. So the rational numbers not only include natural numbers, whole numbers, and integers, it also takes into account fractions. But which kind of fractions? The fractions which are terminating or the fractions which are recurring. Suppose if I write 5 divided by 2, so it is going to give me 2.5. So it is terminating. Okay. If I do say 10 divided by 3, if I write 10 divided by 3, you are going to get 3.333333. It keeps on recurring. So all this, okay, where you get terminating decimal numbers or you get recurring decimal numbers, that came to be known as rational numbers. So the rational numbers now included, okay, positive numbers, negative numbers, and it also included fractions. Then such numbers were discovered like pi, root 2, root 3, and so on. And these numbers, it was seen that these numbers are non-terminating, and these numbers are also giving the pattern which are not getting repeated. Okay, and therefore we cannot write one single value for them. And so the rational numbers are not like this, and hence those were named as irrational numbers. And this together is real numbers. Now the term imaginary numbers. So suppose if I write a fraction, if I write an equation something like this, say x square plus 1 is equals to 0, and I want to find out root of this equation, what am I going to get? I am going to get x square is equals to minus 1. So now I'll get x square is equals to plus minus under root of minus 1. We have studied such numbers where I can write minus sign outside the square root. We have never studied, okay, numbers where I can write, okay, numbers, negative numbers inside the square root. So this became a problem. It doesn't fit into the real number. It doesn't fit into the real numbers, and therefore these numbers were named as imaginary numbers. We'll look into the history when we study complex numbers, why these are even called as, okay, why these are even called as imaginary numbers. So until then, my point is one, denoted by these are called as imaginary numbers. So suppose if I have under root of minus 5, then I can write it as under root of minus 1 into root of 5. But similarly, therefore under root of minus 5 can be written as I root 5. Therefore, wherever you can see this I these imaginary numbers and the combination of say something like this. This is a real number and this is an imaginary number. The combination of real and imaginary numbers is called as complex number which lies in this system only. The complete chapter is complex numbers. Over there. So this is about the numbers which we use in mathematics. Okay. Much of you must have already known much of this. So let's start with the next basics.
Okay, sir.
Okay, today's
Okay, sir.
lecture is all about basic mathematics, where we are going to see only basic of mathematics because these are our fundamentals. If our fundamentals are weak, then we'll face problems in JEE exams. It's not only the JEE exams is not only about solving the numericals, it is also about fundamentals. And that is
Okay,
why
sir.
we are seeing a lot of fundamentals today, which you must have already studied. Next, even numbers. We know if I write something like this 2, 4, 6, 8, 10, 12, and so on, we call them as even numbers. And if I write something like this 1, 3, 5, 7, 9, 11, and so on, okay, we call this as odd numbers. We know that. But we'll go just one step ahead of this and we'll try to understand, can I represent them by some pattern, okay, some rule which satisfies the even numbers? So yes, I can represent with something like this. If I write 2n and I say where n is nothing but a natural number. If you keep on putting the value of n, if you put n is equals to 1, you will get 2. If you put n is equals to 2, you will get 4. If you put n is equals to 3, you will get 6. If you put n is equals to 4, you will get 8. If you put n is equals to 5, you will get 10 and so on. So if you start putting the value of n is 1, 2, 3, 4, 5, 6, 7, but you will get these numbers 2, 4, 6, 8, 10. Okay, so any even number can be given by this formula. Similarly, odd number. Odd number can be represented in both these ways as 2n minus 1, or you can also represent that as 2n plus 1. It depends on the choice what values of n you are going to consider. Suppose I want to start n from 1, 2, 3, 4 and something like this, or do I want to start n from 0? If I want to start n from 0, then this is how we are going to represent the odd numbers. And if I want to start n is equals to 1, then I'm going to represent by this, that is 2n minus 1. So let's first see 2n plus 1. So if I take 2n plus 1, this representation, then my n should start from 0. So the moment you put n is equals to 0, you will get 2 into 0 plus 1, that is 1. The moment you put n is equals to 1, you will get 2 into 1 plus 1, that is 2 plus 1, that is 3, the next number. If you put n is equals to 2, it will become 2 into 2 plus 1, that is 5, which is next number. If you put n is equals to 3, you will get 2 into 3, that is 6 plus 1, that is 7, that is the next number, and so on. But if you want to start from n is equals to 1, then you will have to use second one, 2n minus 1. Now if I put n is equals to 1, then I should get the first number of the series when I put first number of the n. and therefore it has to be 2n minus 1. If I put n is equals to 1, it will be 2 into 1 minus 1, that is 1. If I put n is equals to 2 into 2 minus 1, that is 3. If I put n is equals to 3, 2 into 3, that is 6 minus 1, that is 5. So you keep getting on these numbers of the series. So even numbers can be represented by both this. It can be represented by 2n plus 1 also. It can be represented by 2n minus 1 also. And even numbers can be represented by 2n. All these things are required. Don't consider that these things are not useful. Suppose if I take your physics and go to a chapter called as wave optics, there and not only there are many conditions. This is one of the many of the things when you are going to use it. There, if you want to find out if it is constructive interference or destructive interference, we derive, okay, and then we find out when n is equals to odd, when n is equals to even, and then we have to write this condition. And if we don't know, then we don't understand from where the 2n plus 1 has come, from where 2n minus 1 has come. We don't understand it. Okay, and that is why understanding the pattern is also important. Not only this, let us go one more step ahead, and let me say that if you take an even number, add, subtract or multiply with an even number, you will always get an even number. See, for example, 2 plus 2, 4, even number. Okay, say 8 minus 2, 6, that is also an even number. Say 2 into 4, that is 8, again even number. So if you add to even numbers, or if you subtract to even numbers, or if you multiply to even numbers, you will always get an even number. What about an odd number? If you add and subtract to odd numbers, again you will always get an even number. Say for example 3 plus 5. 3 is also odd and 5 is also odd. You get 8. Okay. Suppose if I write 3 plus 9, so both are odd, I'll get 12. So when you add or subtract, or if I do 9 minus 3, both are odd, I am subtracting, I am getting a 6. So if you add to odd numbers or if you subtract to odd numbers, again you are going to get only an even number. Similarly, if you multiply an odd number with an odd number, then you will get an odd number. Okay, suppose 3 into 1, 3. Suppose 3 into 5, 15. Odd numbers. So when I multiply to odd numbers, I'll get an odd number. But when I add or subtract to odd numbers, I get an even number. So this also should be borne into the mind. Even number is given by a general formula 2n. Odd numbers are given by the general formula 2n plus 1 or 2n minus 1. If I am adding, subtracting or multiplying to even numbers, I'll get an even number. If I add and subtract to odd numbers, I'll get an odd number. And if I multiply to odd numbers, I'll get an odd number. Let's go ahead. So as it's our basic mathematics, we are saying only basic things. Today we'll try to complete this basics and start with the first chapter of our syllabus. Okay. Next, prime numbers. Composite numbers and co-prime numbers. So what are prime numbers? Which are only divisible by itself. The numbers which are divisible by itself only are called as prime numbers. Say for example 2. 2 is divisible by only 2. Say for example 3. 3 is divisible by 3 only. Any other number you are not going to get. Similarly, if I take 5, 5 is divisible by 5 only. 7, 7 is divisible by 7 only. 11, 13, 17. All these numbers which are divisible only by itself are called as prime numbers. Composite numbers divisible by other numbers also. Here I can write 2, then 3, 5, 7, 11, 13, 17 and so on. Okay, composite numbers which are not only divisible by itself but also divisible by other numbers. Say for example 4, then 6, then 8, then 9 and so on. 4 is divisible by 2 also and divisible by itself. 6 is divisible by 2 also, 6 is divisible by 3 also. 8 is divisible by 2 also and 4 also. 9 is divisible by 3. Okay, so such numbers are called as composite numbers, which are not only divisible by itself but also by some other numbers. Next type of numbers are co-prime numbers. So co-prime numbers are numbers whose HCF or GCD is 1. Okay, HCF, that is highest common factor, and GCD, that is greatest common divisor. So if I take any two numbers whose HCF is 1 or whose GCD is 1, then they are called as co-prime numbers. Say for example, if I take 2 and 9. So what is HCF of 2 and 9? The highest common factor between 2 and 9 is nothing but 1. We know that. Okay. So then these numbers 2 and 9 will be called as co-prime numbers. Next. So this is all about the numbers. So numbers are the major part of your syllabus. Okay, I will not say that major part of mathematics, but major part of our syllabus is numbers, and that is why we started with the numbers. Next, intervals. Many times we write something like this. Sometimes we write the numbers in the square bracket. Sometimes we write the numbers in the circular bracket, which you can see second. And then third and fourth, we can many times also write it in the mixed format. Okay, one closed and one is open. That is one square bracket and one is circular bracket. And all of them have different meanings. And these are called as intervals. What do I mean by intervals? It means from this number till this number. I am defining something from one number till another number. So if I write something like this is called as a closed interval. If I write with circular brackets, it is called as open interval. And if I write something like this, then it is called as semi-closed or semi-open interval. You can also call it as semi-closed, or you can also call it as semi-open. Next, closed interval. So what does this closed interval mean? It means include A and B and in between numbers. We have to include these values A and B also, and all the values which are lying between A and B. If I write something like this, open interval, what it means? It means exclude A and B and include in between values. When I put circular bracket, I have to exclude those values and all other values which are lying in between them I have to include. If I put square bracket, then I have to include, circular bracket means exclude. So now here I have square and here I have circular. It means include A, exclude B. Why? Because square bracket is to the A, circular bracket is to the B. Therefore, I will include A, I will exclude B, and in between value should be again included. Now here, open or the circular bracket is to the A, the square bracket is to the B. It means exclude A, include B, and include in between values. So let's see with an example, you will understand it more clearly. Suppose I write something like this, closed interval 1 to 7. It means I will include 1 and 7 and all the in between values. So I will write 1, 2, 3, 4, 5, 6 and 7. So I have included 1 also and I have included 7 also, because here, suppose I write like this 1 comma 7. It means I should exclude these values and I should write all the values which are lying between 1 and 7. So that can be written as 2, 3, 4, 5 and 6. I will not take 1 and 7 because there was a circular bracket over there. Similarly, if I write 1 and 7, something like this, then it means I have to include 1 and I have to exclude 7. So this will become 1, 2, 3, 4, 5 and 6. There is no 7 because there was a circular bracket to 7. Suppose if I write like this, 1, 7. This time circular bracket is given to 1 and square bracket to 7. It means include 7 and exclude 1. So here I will start this time with 2, 3, 4, 5, 6 and 7. Are all the 4 different? You can see it, that all the 4 numbers which I have written are different. And this is only because of this intervals. This is what the intervals mean. Understand this very properly, because when we are going to start with the chapter number 2, that is relation and functions, everything which we are going to write will show by this symbols only, either of the 4 symbols. We are going to show by this 4 symbols only, so understand it here only. You have to include the values, you have to exclude the values. So square bracket means include, circular bracket means exclude, as simple as that. Square bracket means include, circular bracket means exclude. So I hope it's clear about the intervals. Now we'll see the next inequalities. So when I say inequalities means, many times we use this greater than, less than, all these are called as inequalities. So you have something like this symbol, it means greater than, you have this symbol, which means less than. Then furthermore you have like this symbol also. Same, and one more parallel line just below them. It means greater than or equals to, and this means less than or equals to. Okay, so let us learn a little bit about this inequalities. Let us learn how to find out the solution for the inequalities. Suppose I have something like this. Suppose I have this equation as x square plus 4, and I want to find out the values of x such that this x square minus 4 will always be greater than 0. I want to find out such values of x wherein I'll always get, when I put the values of x into this equation x square minus 4, I'll always get that it is greater than 0. I have to find out all those values. So how to solve these inequalities? So in inequalities we don't do like equal to sign, we don't take it from here to there. Okay, instead on one side we'll keep variable, and on the other side, okay, we will keep constant. So what I'll do is I'll add 4 on both the sides. So here this is minus 4, so if I add with plus 4 it will become 0. So this becomes x square is greater than 4. So now if I take square root, I can write x square is greater than root 4. That is, my x is greater than plus minus 2. Whenever you take out anything from the square root, you should always give plus and minus. Why? Because 2 square is also 4. Minus 2 square is also 4. So when I get 4, it can be square of minus 2 also, and it can be square of plus 2 also. And for that reason only, we have to take negative and positive values. So whenever you remove anything from the square root, you should always give plus minus values. So I've got the solution. Now if I want to write into the form of interval, so it is saying you can take all those values which are greater than 2 or less than 2, that is minus 2. It should be greater than minus 2 and greater than plus 2. So greater than plus 2, which means 3, 4, 5, 6. And if I say greater than minus 2, then minus 3, minus 4, minus 5. You can put and see over here. If you put 2 over here, so 2 square is 4, 4 minus 4, 0. 0 is not greater than 0. If you put 3, 3 square minus 4, that is 5. Minus 3 square minus 4, that is also 5. Okay, 4 square minus 4, so that is 16 minus 4, that is 12. Minus 4 square minus 4. Okay, so that will also be 16 minus 4, that is 12. Okay, so now if I want to write it into the interval form, how should I write it into the interval form? So I can write that my values of x should be, it can have minus 2, minus 3, minus 4, it can go up till countless numbers which we represent by infinity. So infinity to minus 2. Now infinity, whenever we write infinity, you should always give a circular bracket, because circular bracket says exclude that value, and we don't know, and we know that infinity is not defined. We don't know what is infinity. Therefore, we cannot include infinity in the calculation. And therefore, whenever we write infinity, we should always write circular bracket. Next, minus 2. When I put minus 2 over here, I'll get minus 2 the whole square, that is 4. 4 minus 4 is 0. And this inequality said that whatever this equation, it should be greater than 0. So 0 is not greater than 0. Therefore, this 2 cannot be included. Since 2 cannot be included, therefore here also I have put a circular bracket. Similarly, when I write this plus 2, so it can take value plus 2, plus 3, 4, 5, 6, 7, 8, 9. How many numbers it can go? Countless numbers. So it can start from 2 and it can go up till infinity. Again, infinity cannot be included because it is not a number. Therefore, I'll give a circular bracket. Similarly, 2. If I put 2 over here, I'll get 0. 0 is not greater than 0. Therefore, 2 cannot be included. Hence, I'll put a circular bracket. And I'll write one symbol which is called as union, which you will understand in the chapter sets. If you don't understand over here, don't worry. It means union means consider this also and consider this also. At this moment, you only understand it like that. This symbol, I've written something kind of U. This is called as union. Okay, so the solution of this, which I wrote it as x, which I got it as x should be greater than plus 2 minus 2, can also be written as something like this in the interval form. Okay, infinity to minus 2, union 2 to infinity, and circular brackets because 2 cannot be included. Is that clear? Have you understood this?
Yes, sir.
Next, suppose if I put this symbol like this thing, greater than or equals to, then everywhere it will become greater than or equals to. So, the value of x square minus 4 should be greater than or it should be equals to 0. So, now when I say equal to 0, which means I can include 2 also, because 2 square minus 4 is going to give me 0, and it says that greater than or equals to. So, here now it will become square bracket. Here also it will become square bracket. Why? Because now I can include these values. Why I can include these values? Because he is saying greater than or equals to 0. And when I am putting, okay, 2 over there, I am getting 0. And that is allowed as per this inequality. Therefore, I am going to give now as a square bracket. Hope you have understood the intervals. This is how we use the intervals, okay, to write the solutions, and this is how we find out the solutions for an inequality. Okay, let us do one more. Let us do one more. Suppose I have something like this. 9 minus x square should be greater than or equals to 0. So I want to find out the values of x which is going to satisfy this inequality. Whenever I do 9 minus x square, I should always get a value which is 0 or greater than 0. Which are the values of x which is going to satisfy this equation? So, like I said, we don't do like equal to. What happens in equal to, you take it over there, this minus becomes plus. But here, if you do over here, okay, and if you change the minus sign, then the inequality changes. And the students get confused, and therefore I don't want you to follow all those things. Instead, it's very simple. The logic is on one side there should be numbers, on one side there should be variables. So if I want variable on this side and I want numbers on this side, I'll add x square on both the sides. So now I'll get 9 minus x square plus x square is greater than or equals to 0 plus x square. So plus x square minus x square it cancels. I'll get 9 should be greater than equals to 0 plus x square will be nothing but x square. So I'll get root of 9 is greater than or equals to x. So I'll get plus minus 3 should be greater than or equals to x. Okay, which can be rewritten as my x should be less than or equals to plus minus 3. So if the value of my x is less than or equals to plus minus 3, then I'll get, okay, I'll be able to satisfy this. Let us put 1 over there. So 9 minus 1 square, that is 8, which is greater than 0, satisfied. If I put x is equal to 2 over there, then I'll get 9 minus 2 square, that is 4. So 9 minus 4, that will be 5. The inequality is getting satisfied. If I put x is equal to just 9 minus 0, which is 9 greater than 0, inequality is satisfied. If I put x is equals to minus 2, then minus 2 the whole square, that is 2. Again, right? The inequality gets satisfied. Now, again, if I want to write that in interval form, how should I write? It should like minus 3. If I go beyond 3, if I take 4, then it will become 9 minus 16, which will be less than 0. Okay, so this can be written as minus 3 to plus 3. Okay, I let x is equals to minus 3 to plus 3. Because if I put minus 3 or plus 3, I get 9 minus 9, that is 0. And 0 is allowed because I have written greater than or equal to. If I change it and if I just write greater than, so if I write greater than, then 0 is not greater than 0. Therefore, I cannot take the value of x, which gives me 0, that is 3. And therefore, the same thing, now I will have to write continuous. I will have to show it by the open interval. I hope you understood how to use closed interval, open interval, and how to find out the solutions to inequality. I hope you have understood. Let's go to the next. Absolute function. Let's go to the next. Absolute function. So before understanding what is absolute function, let us try to understand what is the function. It is always denoted by something like this, and it is read as f of x. In short form, it will be read as function of function of x. In long form, it will be read as function of x. And in short form, you can just read it as f of x. So what is this function? So first understand function, then we'll go to absolute function. So if you are giving any input and if you are getting an output, then this thing will be called as a function. Let us understand a very simple example and then we'll go to the numbers. Suppose if you cut the fruits and if you put it into the mixer, what are you going to get as an output? Output will be a juice. Output will not be, okay, output will not be the fruits. Okay, output is not going to give you fruits. The output is going to give you juice. Okay, so if you cut any fruits and if you put into the mixture or the juicer, and then if you start the juicer, then you're going to get juice. So input were fruits, output is the juice. Whatever fruits you put, that juice you are going to get. So you have an input, then you have something which is going to give you output. So whenever something there, that this kind of thing is there in mathematics, we are going to where you are going to give some input and which is going to give you some output. Then it will be called as a function. Okay. Say for example, let me write x square over here. So if you give input at 2, what you are going to get? 2 square, that is 4. You are going to get output as 4. If you put 3, what output you are going to get? 9. If you put 4, what output you are going to get? 16 and so on. You are putting some numbers and you are getting some output. Similarly, here if I write root x, now if I write input as 9, I will get output as plus minus 3. If I put input as 4, I will get output as plus minus 2. Right? But let us try to understand one more thing. It's not compulsory that for each and every input you should get an output. Let me take the same example. When what you did was you cut the fruits and you put it into the juicer, you start the juicer, you get the juice. But if you put sawdust, if you take sawdust and if you put it into the juicer, are you going to get juice of that sawdust? Are you going to get juice of the wood? No. Right? That wood is not going to produce the juice. So for every input, you are not going to get output. It's not compulsory that for every input you should get an output. You may or you may not get output. So that also should be kept into the mind. So the moment I put minus 1 over here, I'm not going to get any output in the real numbers. If I put minus 9 over here, I'm not going to get any output. If I put minus 4, I'm not going to get any output. So we should be very cautious about the function. Whenever we put the values, it's not compulsory that it should always give some output. It may or may not give the output. So whenever you give an input, you get an output, then that thing will be called as a function. Suppose I write something like this: x square plus 2x plus 3. So now if you put input as 1, so that will become 1 square plus 2 into 1 plus 3. So 1 plus 2 plus 3, that is going to give me 6. If I give an input as 2, then I'll get 2 square plus 2 into 2, that is 4 plus 4 plus 3. So that is 11. So I'm giving some input, I'm getting some output. So I'll call this x square plus 2x plus 3 as also a function. Okay, I'll call this also as a function. So similarly, we have something which we call it as absolute function. So here, when you give input as minus 1, you'll get plus 1. If you put plus 1, then also you'll get plus 1. Which means it will always give you only positive output. Even if you put negative numbers, you'll always get a positive output. Similar to the square one. If I put here minus 2, still I'm going to get 4. If I put minus 3, still I'm going to get 9. So what happens in square? You get the square, at the same time you get only positive values. Same is the absolute function. Whatever negative values you put, you will always get a positive value, but it will not increase. The value will remain same. 1 will remain 1 only, 2 will remain 2 only. Okay? But, okay, but this minus 1 will become plus 1 and plus 1 will remain plus 1. So such a function is called as absolute function. Okay, I hope you have understood what do I mean by absolute function. It is denoted by something like this. Two straight lines. So suppose if I say my f of x is equals to mod of x square plus 1. So now when I remove it from modulus sign, that is absolute, I will get two values. Okay, one I'll get like this, minus of x square plus 1, and one I'll get plus of nothing but x square plus 1. Similar to the square root. When we do square root of 4, what we do? We write plus 2 minus 2. Why? Because plus 2 square root is also 4, minus 2 square root is also 4. Similar thing is happening in absolute. Absolute value of minus 1 is also 1, absolute value of plus 1 is also 1. And therefore, when you remove it from the absolute sign, okay, you will get two values, one positive value, one negative value. So if I write something like this, f of x is equals to absolute or mod of, it is also read as mod of, okay, this is also read as mod of x square plus 1. So I'll get two values, one negative values, one positive values, which can be represented something like this. F of x is equals to minus of x square plus 1 and x square plus 1. So now whenever we remove anything from absolute function, we'll always get two values. One will be a positive value, whereas other will be a negative value. Let us see one more. Let us see one more. Suppose if I write mod of x, okay, plus mod of x square minus 1. Then, now when you remove from mod, you will have to write one positive and one negative. So when you remove this, minus x square minus 1. So this is negative value, and 1 where is the positive value. So this will be plus x, and this will be plus x square minus 1. So whenever you remove anything from mod, you will take one negative value and one positive value. So here I have taken one negative value and here I have taken positive value. Now if I solve, let me take it as x square only. So now I will get minus x square plus 1. So I'll get minus 2x square plus 1. And over here, x square plus x square minus 1, that is 2x square minus 1. So now when I remove this function, okay, this f of x is equals to mod of x square plus mod of x square minus 1. Now when I take a positive value and a negative value and simplify it, I get two values of the function. One value of the function I get it as minus 2x square plus 1, and one value I get it as 2x square minus 1. Is that clear? So this is how, when an absolute function is given, Okay, you can solve
Okay,
that
sir.
equation.
Okay, sir.
Now let's go to the next. We are into the basic of mathematics, therefore we are seeing everything basic. So one is an equation and one is an identity. So you have heard these words, but let us try to understand the meaning of this. Identity. In your trigonometry, you must have learned something which we call it as identity as sine square theta plus cos square theta is equals to 1 is called an identity. Similarly, 1 plus tan square theta is equals to sec square theta. This also we call it as an identity. We don't call it as an equation. 1 plus, okay, cot square theta is equals to cosec square theta. This also we call it as an identity. We don't call it as an equation. Whereas if I write something like this, say sine theta plus cos theta is equals to 3 or say is equals to 0.5. I call this as an equation. Now, so let us try to understand difference between what is an equation and what is an identity. So we have written some intervals today. So what is an equation? If values of x, if only certain values of x satisfy in the interval, and what is an identity? All values in given interval satisfy the equation. So what do you mean by satisfy? Satisfy, which means nothing but LHS is equals to RHS. Okay, whenever you get LHS is equals to RHS, we'll say that it has satisfied the equation. So satisfied means nothing but LHS is equals to RHS. So if I take this sine square theta plus cos square theta is equals to 1, and if I write the values between 0 to 180 degrees, then all the values which are lying between 0 to 180 degrees or 0 to 360 degrees, if you put any angles over here, okay, sine square of 30 degree plus cos square of 30 degree, sine square of 60 degree plus cos square of 50 degree, you will always get 1. Any values which are lying between 0 to 180, all the values if they are satisfying, then will be called as an identity. But only certain values between 0 to 180 degree, if they are satisfying the equation, say for example, if I write sine square theta plus cos square theta is equals to 0.5. So now only certain values which lie between 0 to 180 are going to satisfy this equation. Not all the values of theta. Only certain values of theta are going to satisfy this. And hence, this will be called as an equation and this will be called as an identity. If all the values within the given interval satisfy the equation, then it is called as an identity. But if only certain values within the interval satisfy the equation, then it will be called only as an equation. I hope it is clear with this example what is an equation and what is an identity. So here our basic mathematics is over. This was everything which you have studied up till your 10th standard and some fundamentals which are required. Now, we'll start with the first chapter of your syllabus called as sets. And this chapter will make you realize that maths is not only about numbers. Okay, anyways, most of you had given me the answers wherein, okay, you very well know that maths is not only about the numbers. So this chapter we are going to study a lot of things where we are not going to add, subtract, multiply, divide the numbers. We are going to study a lot many things beyond numbers also. So first, what is the set? Set is nothing but collection of well-defined objects or things. So a collection of well-defined objects, okay, or a collection of well-defined things will be called as a set. Say for example, if I say collection of numbers, so you will start from 1, 2, 3, 4, 5, 6, 7, 8, and everyone in their every language they have these numbers only. Okay, only they'll use some different language, but they'll have the same numerals. If I say, okay, A is a set of fruits, then we'll start writing all the fruits. But suppose if I say A is a set of favorite actress, will the answers of everyone will be same? Will the answer be same? No. Okay, someone's favorite actor will be Surya, the other's favorite actor will be Vijay. Someone will be having favorite actor as Rajnikant. Some other will be having favorite actor as Chiranjeevi. Someone will be having Pawan Kalyan. So many people if are there, everyone will have different answers. So it is not well defined. If I say actors, then all are going to fit into that actors. But if I say favorite actor or favorite actress, everyone is going to give different answers. Okay? So since everyone is going to have different answers, therefore it is not well defined. If I ask anyone, what is this? So anyone from any corner of the world will say this is a green colored chalk, this is a pink colored chalk, and this is a white colored chalk. But everyone in the world will give me the same answer. Everyone will say that this is a chalk. No one will say that this is a wood. No one will say that this is a sketch pen. Okay, no one will say that this is a pen. Okay, if I ask anyone, everyone will say that this is a bottle. No one will say that this is a chalk, which means it is well defined. Everyone is going to give me the same answer what it is. So if the answers are not going to change, then it will be called as well defined. So when we are going to study the chapter sets, we are only going to study the things which are well defined. Set is a maths where the things are only well defined. So maths of well defined thing is only a set. So it is a collection. It will be shown by this symbol. Curly brackets and always by capital letters. So if I say A is a set of first 10 natural numbers, then I write 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, if I say B is a set of vowels, That will be A, E, I, O, U. Anywhere in the world, if you ask, okay, B is a set of vowels, everyone is going to give me the same answer. Any person in any corner of the world, if you ask him, okay, write a set of first 10 natural numbers, everyone is going to write this only. Therefore, it is well defined. So, I am writing, okay, certain things inside and I'm showing it by comma, and whatever I'm writing inside, okay, will be called as elements. So whatever I'm writing inside this set will be called as an element. If I say C is a set of capitals of say two states. So say suppose you are writing Chennai, Mumbai. So if you ask anyone in the world that C is a set of capitals of Tamil Nadu and Maharashtra, everyone is going to write the same answer. Everyone is going to get the same set, Chennai and Mumbai. Everyone. Therefore, it is well defined. Suppose I say D is a set of letters in the word school, then I'll write S, comma C, comma H, comma A, comma L. Now, if you see over here, I did not write O two times. Why? Because as per the rule, one element can be written only once. Why like this? Suppose if you are writing a list, you want to go into the market. If your mother is telling go to the market and bring so and so things, okay? So she'll not tell you soap, then again soap, then again soap, then again toothpaste. She'll not tell. She'll write soap, quantities 3. She'll not say soap 3 times. She'll say soap and she'll write 3 over there. Okay, toothpaste 2, whatever it is. So you will write only once when you are writing the things in the list. When you are writing things in the list form, you will write things only once and there you will mention how many quantities you want. If I want 10 pens, I'll not write pen, 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 pen 10 times. That will be stupidity. I'll write pen only once and then I'll mention over there the 10 pens. I'll write 10 numbers. Therefore, when we are writing something like this, we will repeat things only once. And this form, which I am writing over here, is called as list method, or it is also called as roster form. So the way in which I am writing the sets, okay, that way is called as list method, or it is also called as the roster form. Suppose I am saying E is a set of letters in the word excellent. Then I'll write E, then I'll write X, then I'll write C. E I've already written, so I'll not write L. Then again I'll not write L. E again I'll not write E. So L has come 2 times, but I'll write only 1 time. E has come 3 times, but I'll write it only once, because one element should be written only once. Okay, so this whatever I've written, it is called as list method. Also, it is also called as the roster form. Okay, way of writing sets. There is one more way of writing sets, which is called as set builder form. So suppose the same thing if I want to write. Okay, I will have to write something like this. A is a set of x such that x belongs to natural numbers and where x is less than or equals to 10. So this is what I've written. This is called as set builder method. It may look complex at one moment, but both the methods have their own advantages and disadvantages. Suppose if I say A is a set of first 10,000 natural numbers, then in the roster form, what you will have to do is you will have to start writing from 1 and you will have to continue writing till you write 1000. Isn't it going to take time? It is going to take time. It is going to eat a lot of space and it is going to be a tedious work writing 1 to 1000 numbers. Okay. But if I write in the set builder form, it will become much easy. Now I just have to write over here 1000. That's it. Same thing can be written very easily. So both methods have their own advantages and disadvantages. So when we write in the set builder form, we have to learn certain symbols that as to what these symbols represent. Next, we also have to find out a rule which all the elements satisfy. Say for example, if I write a set of something like this. Okay, 1, 4, 9, 16, 25. Then if I want to write it into the set builder form, then I have to write something like this. F is a set of x such that x is equal to. Now I will have to find out a pattern or a rule which each and every element of this particular thing is satisfying. So if I write n square, where n belongs to natural numbers and n is less than or equals to 5. Okay, so my n is the natural number, which means I have to start from 1, and if I put over here 1 square, that is 1, I'll get the first element. If I put n is equal to 2 square, that is 4, I'll get the second element. If I put n is equal to 3 square, that is 9, I'll get third element. And I have to do up till n is equal to 5, I'll get 25. So I will have to do only up till 5. If I write 6, then I don't have 36 over there. I cannot write 6. Is that clear? So if I write in set builder form, then I have to also work on a specific rule or a pattern that particular numbers or all those elements are satisfying. So sometimes set builder form becomes difficult also. So both the roster form and the set builder form have their own advantages and disadvantages. Wherever roster form is beneficial, there will write in the roster form. Wherever set builder form is beneficial, where it is going to save our time, efforts, and space, there we are going to use set builder form. Both are equally good methods. Okay, our application will decide either we have to write in set builder form or roster form. So today we have learned what is set, what are ways of writing a set, how we can represent a set. Okay, so in the next lecture we'll start from where we have left. Okay, uh, I'll send you the recorded video. Okay, I'll send you the link for the recorded video, and those who have faced network problems, network issues, okay, they can see those video.
Yes,
Have
sir.
a nice day.